In my sessions over the last 3 days, we've looked at information and computation and automation and how they fit together to make a series of blocks, a program you can run to control your microbit. You might have a start block at the top that sets some variables or some information that you've collected from the world. And then you might have some if-then statements or some for loops, some automation, and then you eventually get to a result. How you execute these statements one by one as you proceed through your program is sometimes referred to as control flow. And what I want to illustrate today and tomorrow is how you can use very similar statements and by executing them in a slightly different way, achieve quite different results. And to pursue this, I'm going to use the example of a combination lock. You can think of a combination lock as a PIN number or a password or your passcode to get into your phone. Any situation where you have a series of digits or could be letters and you're trying to guess what they are. Personally, for the purposes of this problem, I like to think of a combination lock as one of those old safes you see in movies that has the dial and you twist it and you get to a number 4 and then you know it's the right number and you twist it again and it's another number 1 and you're trying to get the overall combination to the safe so that you can crack the safe. So today's session, in terms of the Wyoming computer science domains, is going to focus on algorithms and programming, and specifically on variables, control, and modularity. And we'll also touch on data visualization as an aspect of data analysis. Now that we've spent a few days discussing automation using loops to go through a process many times, I now want to get back to thinking about other aspects of computation. In the first few days, we discussed if-then logic, how you can take some input to your code and depending on certain conditions, you can do one thing or else you can do another thing. And I want to think about another aspect of this process. That aspect is sometimes called control flow. It's the idea that it matters in which order you execute your statements. And as I mentioned earlier, I want to use the idea of a combination lock to illustrate control. So to think about a combination lock and the problem I'm going to set up today, you're going to need to know about another couple of things that your microbit can do. One of those is being able to choose a random number for you, and the other is how you display certain numbers on the LED display of your microbit. So to begin with, let's show you how to pick a random number. Under the math drawer, you'll notice that there is an option to pick a random number between 0 and 10, and you can choose 0 and 10 to whatever you would like. I'm going to set up a variable, which I've called lock1, which makes sense if we're going to be talking about combination locks. And on the starting point, when we begin the program, I'm going to set that variable lock1 to be a random number between 0 and 4. So when our code first executes, this lock1 number is going to be between 0 and 4. This is the number we're going to try and guess. It's the first number in our combination lock. Somebody has hidden a code between 0 and 4, and we're going to try and guess what it is. It helps to illustrate the problem and how the microbit has chosen this number if we display the number it's chosen. So let's go back to just showing numbers on the screen as we were doing before. And instead of a particular number, we're going to show a variable, and that variable is this lock1, this number that has been set to a randomly chosen number between 0 and 4. So every time we execute the program, the microbit will pick a random number, and that number will be some number between 0 and 4, as in what I'm illustrating over on the side screen here. So the next part of this process is, instead of just showing the number, displaying the number to screen, I would like to light up an LED that corresponds to that number. Your LEDs here on the screen are numbered 0 to 4 from left to right. So this is 0, 1, 2, 3, 4. And 0 to 4 down the columns. So 0, 1, 2, 3, 4. If you hover your cursor over a particular LED, you'll see the number it corresponds to. So this should be 40. So instead of just displaying the number on the screen, let's plot the number in the first column, so x equals 0, and the number we're going to plot is whatever random number was chosen, so lock 1 here. So just the same as showing the number, except we're going to light up the appropriate LED. So let's try this. First time through, the microbit picked the number. Well, you can see if we highlight this, it's 0, 0, so it picked the number 0. Next time through, picked 0 again. This time, it's picked 2. You can see that we're in the 0th row, but we're in column 2. The 0th row, and it picked the random number 2. Try again. And one more time, it picked 0 again. Fun thing about random numbers is you can just keep getting the same number over and over. Finally, it picked 3. So that's one concept related to the problem I'm going to set up. The next idea is that we're going to try and guess that number. I'm going to get you to execute a loop that every time button A is pushed, you guess a particular number. So the guess is also going to be a random number between 0 and 4. And once we have that random number between 0 and 4, let's also plot that, guess 1, but we're going to plot that in the second column, which corresponds to x of 1. So for example, all of the LEDs down this column correspond to x of 1. So 1, 1, try again, 1, still in row 1, but now 3, we were 2, sorry, still in column 1, now we're in row 4. This is column 1, row 0, column 1, row 1. Apologies, my cursor isn't highlighting them very quickly, but column 1, row 2. So we're going to stay in column 1 and plot our guess. So here we go, let's do this a few times. For the lock, the microbit picked the number 0, 1, 2, 3, and we guessed the number 0, 1. Try again. The microbit picked number 1 and we guessed 1. Well done us, we got it right. The microbit picked 3 and we guessed 3. The microbit picked 2 and we guessed 2. Sorry, 1 and we guessed 1. The microbit picked 1 and we guessed 2. So this is the general idea. But here's the problem I want you to try and complete today. I want you to set up a combination lock consisting of one number, a number that is randomly chosen between 0 and 4. When button A is pressed, not just on start, but when button A is pressed, you're going to generate a guess. And that guess is another random number between 0 and 4. Every time the button is pushed, you're going to keep the same lock random number, but every time the button is pushed, you're going to generate a new guess. And if the guess is correct, then display in this column, which corresponds to x of 0, display the number, but only if the guess is correct. So light up the corresponding LED if the guess is correct. It might be this one if the guess is 0 and it's correct, this one if the guess is 3 and correct, this one if the guess is 2 and it's correct, but light it up. So the question I want you to answer is, how many times do you have to push button A to get the guess correct? on average. So once you've written your code, try pushing button A a few times and see how many times you have to push it until the LED lights up, meaning you've got the correct guess. Is it 20 times? Is it 5 times? Is it 1 time every time? You should be able to sort of have a hint of working out what the answer is in advance, but try the experiment anyway. Once you've done that, a stretch goal is to set up a second column in the combination lock. Lock 2, we'll call the variable, and lock 2 is also going to be a number between 0 and 4. When you push button B, you're going to generate guess 2, a number between 0 and 4. And then the stretch goal question is, how many times do you have to push button A to guess the number, plus button B to guess the number? So you push button A and maybe you push it 3 times and it lights up the LED in this column, you've got it right for lock 1. Push button B, have you got it right for lock 2? So write code first to just generate pushing button A and trying to guess the correct number. And then as a stretch goal, a second block that does the same thing but when you push button B. And how many times overall in combination do you have to push A and B to get to the right 2-number answer to break the combination lock? And I'll be back soon to show you my solution to this problem.